Jai Hind everyone. I am Dr. Suman working as an assistant professor in the Department of Mechanical Engineering at AKGEC Engineering College, Ghaziabad. So today we are going to discuss about the different transportation methods. Okay, and it is a part of the subject operation research, and the targeted students will be the BTech and MTech students. And the subject code for the BTech student is KME 503 and for MTech is MTME 102. So transportation problem. If we talk about this transportation problem, so it is a very critical issue in case of the optimization, and we want to optimize the transportation cost. So when first we will discuss about the outline of today's lecture. So we are going to discuss these points. First we will see what is the meaning of the transportation problem. So we will have the introduction to transportation. Then we will see the classification of the transportation problems, means what are the different methods through which we can solve these issues. And after that we will take one example and then we'll solve it with the help of different techniques. Okay. So if we see the objective of the transportation problems, okay. So here the objective is to minimize the cost of transportation, okay, from one place to another place. Or we can see here that the transportation problem objective is to minimize the total cost of transportation from supply center to the demand center. Okay, so there will be two centers, one will be the supply center and one will be the demand center. Okay, so to satisfy a particular demand, we have to supply the material. Okay, then the cost will be involved in transporting, so we will minimize this cost. Now we can see here there is a mathematical model. So when we talk about the transportation, we have two things. One is the distribution center and one is the supply center. So in this particular matrix, which is known as the transportation matrix, we can see here these D1, D2, D3 and D4. These are basically the four distribution centers. Okay, and these S1, S2, S3 are the supply centers. Okay, so we are satisfying the requirements. Clear? So you can see here the supplies means at S1, okay, at S1 center the supply is 7. Okay, the supply which is available at S1 center is 7. At S2 it is 9 and at S3 it is 18. Okay, this is the supply. Now what is the demand of the D1 distribution center is 5. This is demand or the requirement. At D2 it is 8, at D3 it is 7 and at D4 it is 14. Okay, so these two terms are the supply and distribution. Now we can see here these terms. These are basically the cost involved in transporting the material from one place to another place, or we can see say that from supply center to the distribution center. For example, if we see here S1 to D1, if the material is transported from S1 to the distribution center D1, then the cost involved is 9. Okay, the cost involved is 9. Okay, from S1 to D2 it is 30. From S2 to D2 it is also 30. From S3 to D2 it is 8. So these are the terms which will be involved in a mathematical model or the transportation matrix. Clear? The another thing which is important is, if we want to solve a transportation matrix, then what we have to see that the total demand should be equal to total supply. Then it is, if the total demand and supply are equal, then it is known as the balanced problem. Means one of the conditions is the total demand should be equal to total supply, or total supply should be equal to total demand. Okay. So if this is the condition, it means our transportation problem is balanced 1. Okay. So we can see here the total supply is 7 plus 9 plus 18, which is 34, and the total demand is 5 plus 8 plus 7 plus 14, which is also 34. Means the total supply is equal to total demand here. So this is a necessary condition. Clear? Now we come to the various steps for solving the transportation problem. Okay, so we will solve our problems step by step. So first one is the formulate the problem. Okay, what is the meaning of formulate the problem? Means we have to convert the descriptive statements into the mathematical form. Okay, so first we will formulate our problem, then we will see whether our problem is balanced one or not. So for the balanced, for this condition, to check this condition, the requirement is that the total supply should be equal to total requirement. If the transportation matrix is satisfying this condition, it means the problem is balanced one. But if the supply is not equal to requirement, then what we will do? We will balance our transportation problem. How we will balance it? We will add a dummy source or the destination as per the requirement. Okay, will be created to balance the problem. Whether so in case of the unbalanced problem, we will add a dummy supply column or the demand row. Okay, that determine the initial basic physical solution, IBFS. After that, we will determine the initial basic feasible solution, and we can check the optimality also. And for checking the optimality, this condition should be satisfied. Means m plus n minus 1 is equal to number of allocations. Okay, then we will update our solution. So these are the different steps we will use for finding out the solution. Clear? Now we come to the different methods to find out the initial basic feasible solution. So we will use these 5 methods for solving the transportation matrix. So first one is the northwest corner method. Okay. The second one is the least cost method. Then we have the Vogel's approximation method, which is also known as the VAM method or the penalty method. Then we have the row minima method and the column minima method. So these are the methods which we are going to use in the coming slides. So now we have taken one example. So in this example, we will see what is given. A dairy farm has 3 plants located throughout the state. The daily milk production at each plant is as follows. Plant 1, 6 million liter, plant 2, 1 million liter, and plant 3 is 10 million liter. So, what is given? There are 3 plants, plants 1, 2, and 3. And the supply or the production which is available with the plant 1, 2, and 3 is given to us. So this is the S1, S2, and S3, or P1, P2, P3. Means this much of milk is available with them. Now each day the farm must fulfill the needs of its 4 distribution centers. So 3 are the supply center and 4 are the distribution center. Minimum requirement at each of the center is, so distribution center 1, the requirement is 7 million liter. Distribution 2, center 2, the requirement is 5 million liter. At distribution center 3, the requirement is 3 million liter. At distribution center 4, the requirement is 2 million liter. The cost of shipping 1 million liter of milk from each plant to each destination center is given in the table in 100 of rupees. So one table is also given in which the cost for transporting the milk from the supply center or the plant 1, 2, 3 to the distribution center is given in terms of 100 of rupees. Okay, so we converted this into the transportation matrix. So we can see here there are 4 distribution centers, D1, D2, D3 and D4, and these are the supply centers, means plant 1, plant 2 and plant 3. This is the total supply which is available with us in the million liters, 6, 1 and 10, and this is the total demands or the requirement of the distribution center, 7, 5, 3 and 2. So first we will see here whether our problem is balanced one or not. So we can see here 7 plus 5, 12 plus 3, 15 plus 2, 17. Okay, and here 6 plus 1, 7 plus 10, 17. Means here the total supply is equal to total demand. Means our problem is balanced one. Okay, now we will solve this problem with the help of the different methods. So first we are going to use the northwest corner method. Okay, so there are some steps for this. First step is we will start from cell 11, C11. C11 is this one. So we will start from here. Okay, and we will proceed horizontally if DI is less than SI. Okay, if SI is greater than DI, it means we will move horizontally for the next cell. And if DI and SI are equal, then we will move diagonally. And if DI is greater than SI, then we will proceed vertically. So these are the steps for selecting the next cell. Okay, so we have already checked this step that the total demand total supply is equal to total demand here, and we can check the feasibility also. And for the feasibility, m plus n minus 1 should be equal to number of allocations. Here m is basically the number of rows, n is the number of columns, minus 1 is equal to allocations. So here the row are 3 and the columns are 4. So 3 plus 4, 7 minus 1, yani 6. So allocation should be equal to 6. Okay. So first we will see how we will proceed. First we will take cell 11, C11. Okay. C11 is this one. So now we will see the supply which is available against this is 6 and the requirement is 7. But the supply which is available with is 6 only. It means we can satisfy the demand of 6 units only, 6 million liters only. Okay, so if we satisfy the 6, then what will be remaining here? 1, and this will become 0. And we will allocate the 6 here because 6 million liter demand is satisfied here. Now we will see where we will move. Then we can see here the SI. SI is 6 and DI is 7. Means DI is greater than SI. It means we will move vertically. So if we will move vertically, we will come to this. Now the supply against this is 1 and the demand is also 1. Means we can satisfy the demand here. So it will become 0 now. And it will be the 1 here. Clear? Now we will see it was 1. It was also 1. It means DI and SI are equal. Okay, demand and supply were equal. So we will move diagonally. So when we will move diagonally, so we will see here. We will select this cell. Now we will see the demand against this is 5 and the supply available with is 10. It means we can satisfy the demand of 5. So the remaining will become 0, and here we can satisfy 5, and it will become 5 now. Clear? Now the condition was the SI was greater than DI. It means we will move horizontally. So we will come to this side. Okay. Now the demand against this is 3 and the supply available is 5. Now we can again satisfy the demand of 3. So it will become 0 and it will become 2. Okay. Now we will check again the SI was greater than DI. It means we will again move horizontally. We will come to this side. Now we will see what is available. Supply available with us is 2 and the demand is also 2. It means it will become 0. It will also become 0 and 2 will be assigned here. So in this way we can allocate. We can find out the allocation and we can satisfy the demands. So if we want to find out the transportation cost, what we will do, we will multiply these terms, means this cost with the satisfied demand. Okay, so we will see here 2 into 6 plus, then we have 1 into 1 plus, then we have 8 into 5 plus, we have 15 into 3 plus, we have 9 into 2. And there are 1, 2, 3, 4, 5. Okay, there are 5 allocations. Okay. So it comes out to be 12 plus 1 plus 40 plus 45 plus 18. Okay, rupees 116. Okay, so this will become the total transportation cost. Clear? So in this way we can find out the transportation cost with the help of the northwest corner method. Now we come to the least cost method. Okay, so in case of least cost method, what we will do, we will find out the least cost in the transportation matrix. Okay, so we will see here what is the least cost. This one is the least cost. Okay, so we will assign here. So we can see here the supply is 1 and the demand is 5. So we can assign, we can satisfy the demand of 1 only, because the supply which is available with us is 1 only. So it will become 4 here. Okay. Now this will, we will cancel out because the supply available is 0 with us. So now the P2 is cancelled out. We will not consider this P2 for the further analysis or the further analysis. So now what we will do, we will have the 2 rows only, P1 and P3. Now we will see what is the least cost here. This one, 2. Okay. So now we will see what is the supply against it. It is 6 and the demand is 7. So we can satisfy the demand of 6 here. So it will become 1 and it will become 0. So now against P1 the supply available is 0. So we will again remove it for the further analysis. Now we have only 1 row with us. Clear? So we will see what is the least cost. This is 5. So we will see what is the supply available with us is 10 and the demand is 1. Means we can satisfy the demand of 1. It will become 0 and it will become 9. So we will cancel out this. Clear? Now you can see in this one matrix we have only D2, D3 and D4. Now the least cost is 8. Now we will see the supply available is 9 and the demand available is 4. It means we can satisfy this demand. It will become 5. So we will cancel out this one. Clear? Okay. So we can do it. Now we have D3 and D4 only. Now we will consider D4 because it is the least cost. So we will see here that the demand available is 2 and the supply available is 5. So we can satisfy the demand of 2 here. Okay. So it will become 0 and it will become 3. Now the last one is D3. So we will assign here demand and supply are equal 3 and 3. So it will satisfy the demand of 3 here. Okay. So in this way we will allocate the cells in the least cost method. Now we can find out the least transportation cost. So we have to see what are the assigned cells. 0, 1, we will write 1 here. Then we have 2, 6. We will write down 2, 6. Then we have 5, 1. 5, 1. Then we have 4, 3 and 2. 4, 3 and 2. So these were the allocated cells. Now we will find out the total transportation cost in the same manner as we did in the northwest corner method. So we will write down 2 into 6 plus 0 into 1 plus 5 into 1 plus 8 into 4 plus 15 into 3 plus 9 into 2. Okay. Now we come to the next, that is the Vogel's approximation method. So in case of the Vogel approximation method, first we have the two cases. First one is the minimization problem and the second one is the maximization problem. Okay. So in case of the minimization problem, what we will do, we will calculate the penalties. Okay. We will calculate the penalties by subtracting the smallest and the second smallest element in each row and column. So here what we will do, we will find out the penalty row wise and the column wise. And if it is the case of the minimization, then we will select the minimum cost and the second minimum cost in the respective row or the column and we will subtract it. Okay. Then we will select the row or column with the highest penalty and allocate the minimum cost. Okay. And in case of the tie, we can select any one. After one allocation, we will calculate the penalty again and repeat the iterations until all locations are assigned. Okay. So these are the steps in case of the minimization problem. But in case of the maximization problem, what we will do, we will always take the difference of the highest and the second highest cost in each row and column. And then we will select the row or column with the highest penalty and allocate the highest cost. Okay. So in case of the minimization cost, what we were doing, we were selecting the highest penalty, but we were assigning the minimum cost. But here we are selecting the highest penalty, but allocating the highest cost. In case of the tie, we can select any one, and after one allocation we will calculate the penalties again and we will repeat the iterations until the all locations are assigned. So these are the steps in case of the Vogel's approximation method. Okay. Now what we will do, we will take one example here. We are taking the same example and we will solve it with the help of the Vogel's approximation method. So first what we have to do, we have to find out the penalties. I am assigning the penalty as P1. Okay. And if we will calculate the penalties row wise and for column wise. So I am writing the P1 and against the row column, and P1 against the this row wise also. Okay, so what will the penalty? What are the two minimum costs? 2 and 3. So we will take the difference of these. 2 and 3 difference is 1. Here it is also 1, and here it is 3. If we see this one, so it will become 1, it will become 3, it will become 5, and it will become 6. Okay, these are the penalties. Now the second step was we will select the highest penalty. Highest penalty is this one. So we will go against this column. Okay, highest penalty. Now we will assign the least cost. Least cost is here. So we will assign here. So we can see here that supply against this is 1 and the demand is 2. So we can satisfy the demand of 1 only. So it will become 1, it will become 0, and we will assign 1 here. Okay, and after that what we will do, we will again find the penalties. Okay, so we can see here in the last one, so supply against this is 0, so we will not consider it for the further analysis. Now we have P1 and P3 with us, so we will again find out the penalties. I am assigning it as the P2. So if we see here, so it will become 3, it will become 5, it will become 4, it will become 2. It is 1 and it is 3. Okay, now we will go for the highest penalty. Highest penalty is this one. So we will take this column. Okay, so least cost is this one. So we will see supply available with us is 6 and the demand is 5. So we can satisfy the demand of 5 here. It will become 1. So we will cancel out this. Okay. Now what we can do, we will again have the D1, D3 and D4 only. Now we will find out the penalties. So it is 3, it is 4, it is 2, and here P3 is 2 and it is 4. Now what we will do, we will take one of the, for example, if we are taking this one, so it will become, we can assign against this, we can assign here 3, it will become 3 and it will become 0. So we will cancel out this one. Clear? So in this way, we can do it. We will again calculate P4, here P4. So P4 क्या हो जाएगा 3 and here it will become 2 and it will become 5 and it will become 4. So we'll take this. So we'll go for this. So least is this one 3 or 7. So it will become 4 and it will become 6. So this one will be cancelled out. Now we will take this one. So we will assign against this. So it will become 4. It will be 0. It will be 6. Then we will go for this. So we will assign here 2 become 0. Clear? So in this way we will assign the cells. After that we can find out the transportation cost. So for finding out the transportation cost, what we will do, now we have assigned these 1, 5 and this one was 6, this one was 3 and this one is 1 and this one is also 1. Okay, so now we can find out the transportation cost as 2 into 1 plus 3 into 5 plus 1 into 1 plus 5 into 6 plus 15 into 3 plus 9 into 1, which comes out to be 102. Clear? So we can see here that we get the least cost with the help of this method. Clear? Now we have the row minima and the column minima method. So in case of the row minima, what we will do, we will take the basically assign the first row and then we will follow the row sequence having the minimum cost. Okay, and then we will assign the cells, and then in the same manner we can find out the transportation cost. Same we will do in the column minima method, means we will assign the lowest value in the first column and then we'll follow the column sequence and we will find out the transportation cost. So this is all for today's lecture. Thank you so much.